Just a reminder, a common logarithm is a logarithm of base 10, and we don't write the base, right? So this is the one weird place where if you don't see a number, you assume the number is 10, okay? So what we're doing is trying to solve equations that look like this, right? So it'll be 6 to the x minus 15, and it doesn't have to be 0 over here, okay? But what you want to do is isolate the term with the exponent. So the term with the exponent in this equation is 6 to the x. So we're going to get rid of the minus 15, so we bring it to the right. And then we're going to take the log of both sides, right? Doesn't matter what kind of log you take. I prefer the common log. It's the easy one. If you look at a typical calculator, oops, camera fell down. If you take a look at a typical calculator, there is a log button, right? And there's a natural log. You can use either one. I'm going to be using the LOG button, right? So you can just take the log, you turn on the calculator. Oh, you can't see that. All right, so let's leave it alone. All right. All right, so we take the log of both sides. You're going to use the power property of logarithms, meaning you take that exponent and it becomes a coefficient, and then you're going to divide by log 6 because it's x times log 6. That's how we get this log 15 over log 6. And we just throw that puppy in the calculator. That's it. All right, let's do some examples. So example 1a, we're going to take the log of both sides. So it's log of 15 to the x equals log of 53. Okay, now we bring the x down, so it's x log 15 equals log 53. Now we just divide by log 15, so x equals log 53 divided by log 15. And you put that in the calculator. Do I have another calculator? Oh, no, I guess I don't. Okay. Can you put this in the calculator? Why is this so bad? There we go. All right. Let's try that. So what we're going to do, clear that out. So we're just going to put in the calculator log of 53. Notice it automatically creates parentheses, close that parentheses, and then divide by the log of the other number, which is 15. And we're going to get 1.466. It says round to the nearest 10 thousandths. So that's tens, hundreds, thousands, 10 thousandths. Really? We want 10 thousandths? Tens, hundreds, thousands, tens. So 4 decimal places, 1.4661. So we're going to say it's 1.4661. All right. And let's look at the next one. So you want to isolate the 20 to the x. So you got to subtract the 2. So that's the 20 to the x equals 72. Now you take the log of both sides. So it's log of 20 to the x equals log of 72. So you bring the x forward. Log 20 equals log 72. Divide by the log of 20. So x equals log 72 over the log of 20. At this point, you go to the calculator. So that's going to be, let's clear that out, log 72 divided by log of 20. You might wonder why I don't bother to close that parentheses. Okay, it's not a bad habit to close the parentheses, but if it's the last parentheses and there's nothing after, you don't really need it. So it's 1.4276. So we say it's 1.4276. That's what x is. All right. And then c. So here you got negative 5 times that. So we're going to divide by negative 5. So that's going to be 16 to the x plus 3 equals 3/5. Okay, since we're going to be dealing with decimals, you can just change that to 0.6 if you wanted. Now we're going to take the log of both sides. So it's log of 16 to the x plus 3 equals log of 0.6. Bring down the exponent, so it's x plus 3. Log of 16 equals log of 0.6. Divide by log of 16, so it's x plus 3 equals log of 0.6 divided by log of 16. Okay, continue, get rid of that plus 3, so it's x equals log of 0.6 over log of 16. Right, to get rid of that plus 3, you subtract 3, so you subtract 3. All right, that's it. So let's put that in the calculator. So I'm going to do log of 0.6 divided by log of, can't read my handwriting, 16. This time I have to close the parentheses because I'm going to do minus 3 afterwards. Just put that whole thing in the calculator. And I got negative 3.184. negative 3.184, and that's not enough decimal places. I need the fourth one too. So that's C, D. All right, so this one you got to divide by 10 first. So 6 to the 6n plus 4 equals 81 over 10. I'm being lazy here. I'm just going to change it to a decimal. Since we're dealing with decimals, just change it to a decimal. Now we take the log of both sides. All right, so it's log of 6 to the 6n plus 4 equals log of 8.1. All right, and then the exponent comes down, so 6n plus 4 times log of 6 equals log of 8.1. So you're going to divide by log of 6, so 6n plus 4 equals log of 8.1 over log of 6. Continuing. All right, now we're going to just subtract 4 from both sides. So 6n equals log of 8.1 over log of 6 minus 4. At this point, I want to just put this in the calculator. Log of 8.1 over log of 6. Oops, calculator over here. All right, so log of 8.1 divided by log of 6. Close that parenthesis. And then we're going to subtract 4 and give me that answer. Now, here's the thing. I still have a 6 on that variable. So now that I have this messy decimal in the calculator, I'm going to divide this by 6. So just divide by 6. So I got negative 0.4721. So it's negative 0.47, wasn't it? Negative 0.4721. There you go. That's that one. And we're going to do 2 more solves and the last part. All right. Here we go. Okay, so this has multiple steps. I'm going to get rid of the 2 first. So I'm going to subtract 2 from both sides. So that's negative 8.16, negative 6x minus 7 equals negative 34. Divide by negative 8. So 16 negative 6x minus 7 equals, let's go ahead and just change that in the calculator. So change it to a decimal rather. So it's negative 34 divided by negative 8, and I get 4.25. So let's call it 4.25. Now I'll take the log of both sides. So it's log of 16 negative 6x minus 7 equals log of 4.25. Bring down the exponent, so it's negative 6x minus 7 times the log of 16. Go ahead and divide by log of 16. So it's negative 6x minus 7 equals log of 4.25 divided by the log of 16. I'm going to go ahead and add 7. So it's negative 6x equals log 4.25 over log of 16 plus 7. All right, let's go and put that puppy in the calculator. So log of 4.25, close parentheses, divided by log of 16, close parentheses, and then I have a plus 7, so add 7. Press enter, and I have this, that's messy, right? That's this, that's all this, but it doesn't include this negative 6, so I'm going to divide this answer by negative 6, so divide by negative 6. And I get that answer. So I'm going to say x equals, or x is approximately, negative 1.2536. Okay, that's it. Let's look at this one. Last solving problem. Yes, I know it's been a lot. So add 9 to both sides. So I got negative 3, 4 to the 9 minus n equals 33. Divide by negative 3. So that's going to be 4 to the 9 minus n equals negative 11. At this point, you should realize you have 4 to some power, and it's saying it's equal to negative 11. Uh-oh. That's impossible. So at this point, you can say it's no solution. You cannot have a positive number raised to any exponent where it produces a negative number. So we say it's no solution. Okay, but let's say you forget that this happens, which is likely. So you just go through the process. So log 4, 9 minus n, log of negative 11. And maybe at this point you realize, wait, I can't take the log of a negative number. So there's no solution. Okay, but let's say you forget that. So you bring down to 9 minus n, log 4 equals log minus log of negative 11. And you continue forgetting that you can't take a negative log or a log of a negative number. Okay, and then you go, oh, let me put that in the calculator. You go log, just put in the calculator, you go log, negative 11, divided by log of 4. And oops, error, it doesn't work. Oh, now I remember, you can't take a log of a negative number. So this is no solution. Okay, but if you realize it up here, you can realize it right here. You can't take positive number, raise it to a power, and get a negative answer. So if you realize it up here, you can put no solution. All right, you don't need to go all through these steps. Say it's no solution. If you spot it up here, you can stop there. Okay, but if you were at one step and realize, oh, I can't take a log of negative, you can stop there too. So you can stop any point after that. All right. Okay. Or you can just stop when you put in the calculator, error. All right. Okay, so here, this is a change of base formula. What is a change of base formula? Well, the idea here is like on a typical calculator, it's real easy to do common log and natural log, right? There's a common log and a natural log. But there isn't a log base 7 or log base 12 like you've seen these examples of. So what you do to change it from, say, log base, so let's say what I'm trying to do is calculate this value. So you can just rewrite it as log of 18 divided by log of 7. So you don't have to find where in a calculator where this lives. You can just do this, log of 18 divided by log of 7. So what does that mean? So I'm just going to put this in a calculator like this. So this is the same thing as log of 70 over log of 4. So I'm going to put it in a calculator like that. So it's log of 70 divided by log of 4. That's it, 3.0646. 3.0646. Now, if you're wondering, we're thinking like, I don't know if I believe you, Mr. Schweitzer. Okay, so this has logs on here, if I can find it. Can I find it? Maybe not. No? Is there a log on here? There it is. There's log. Okay, so it puts the base on there, so it's 4. Put the 70 in there. And it's the same thing, okay? But you saw how much work it took to get that log phrase for it. It's easier to just do log of 70 divided by log of 4. Okay, that's it. So this one is just log of 1.26, log of 1.26, close parentheses, divided by log of 5. Right, you just log of the base. Close and percenter, 1.1436. 0.1436. Oh, I forgot to change it. So this is log of 1.26 divided by log of 5, right? Take log of the argument over log of the base. And here you go, log of a negative number, undefined. You can't take log of a negative number. So that's it. Thank you.